Let's pause this for a second. What is really happening here, and how do we get to this point? Well, keep your head back, face forward, and hold on as we talk about the science and physics behind amusement park rides. Roller coasters must go up to come down, and this is often accomplished by using a chain lift system or a cable that pulls the train up the track. Not only does this build anticipation for the rider, but it also builds something called potential energy, which will be used to go down the drop as the train gets pulled by gravity. Potential energy built via height gets released as the train goes down the drop and is released as kinetic energy, which in this case equates to speed. As the train ascends a hill, the potential energy rises again and kinetic energy drops. The motion of a roller coaster constantly shifts the energy as the train ascends and goes back down the hills. One major factor that makes a roller coaster exciting is the unusual forces that you'll feel while you're on it. This is called G-force, and one of the main goals of a roller coaster is to sequence the forces in the best way possible for the rider. When descending a drop, you experience a negative vertical G-force as the train accelerates down. Another way that riders are entertained is the use of inversions, such as loops, corkscrews, barrel rolls, and bank turns, which create positive G-force, which feels like being pressed down into your seat. The reason that it feels like you're getting pushed into your seat is because you really are. If you're on a roller coaster and you experience 3 G's of force, that means your body feels like 3 times its own weight. Some of these elements also cause the rider to experience something called lateral forces, which is both the left and right movement of the train and the rider. The opposite of positive forces are negative forces, which is the feeling of weightlessness or being pulled out of your seat. The most common way of providing this force is through airtime hills, which causes the riders to experience negative 0.25 to negative 2 Gs of airtime. It's time for a question. What do you think the most influential theme park is? Well, it's time for a trip to Disneyland, one of the most influential theme parks in the world. So, right now you may be wondering, how does Disneyland have anything to do with the physics and science behind roller coasters? Well, in the 1950s, Aero Development Company, or better known as Aerodynamics, but currently called Sansei Technologies, was set with a mission to make a bobsled-style ride for Disneyland, Anaheim, California. Does that sound familiar? Well, Ed Morgan and Carl Bacon designed the first steel coaster by using steel rails and nylon wheels, which was called Matterhorn Mountain Bobsled. Well, if the track causes the ride to be more intense, how does the train just not fall off the track? Well, it's all thanks to the wheels, and there are actually 3 types of wheels. The first type of wheel are called the road wheels, and what these do is they hold the weight of the train as it goes along the track. These are the most important, and you can think of them as the wheels on your car. Next, you have the side friction wheels, and what these do is they hold the train on the track as it experiences lateral movement. And then finally, we have the upstop wheels. These are for when there's negative forces and the train lifts up, and they keep the train from doing this. This evolution allowed for more intense rides, faster speeds, and made them smoother than their wooden counterparts, which this is the main reason that Matterhorn bobsleds was such an important roller coaster for its time. So the next time you pull down a restraint, remember what it took to get there. Roller coaster.